Hello, I'm an old guy and I do maths. And what we're going to try and do today is to graph this function. Um, it may not be obvious from the heading on this piece of paper, but that's what we're going to do. And the function is negative 3 log 2 4x. And we have some basic questions to answer. Um, First of all, what does the negative 3 do? Secondly, what does the 4x do, particularly the 4? And of course, what does this graph look like? And for the English students amongst you, I'll put a question mark there. We'll get that right at least. Okay, well, we've got a few things to deal with. Now, you'll have come to this hopefully because you've already seen, already know what a basic log graph looks like. I've drawn one in here, and we're going to use that as the template for comparison when it comes to what this particular function graphs like. So I'll just write that in here so that it's always in the shot. So y is equal to negative 3 log 2 of 4x. Okay. Well, here's our standard log graph, which is a reflection in the line y equals x of an exponential graph. And so, surprise, surprise, as a standard exponential graph passes through 0, 1, so the log graph passes through 1, 0. It is the inverse of this and a reflection in that line. So the first thing we're going to look at is what effect the 3 has. We're not going to get to the negative 3 just yet. We'll just deal with the 3. And just excuse my artwork. It's not going to be perfect, but this is roughly what y equals 3 log x would look like. And you can see what's happening. This thing is a dilation factor, and it's sending the y values further away from the x-axis. That's its effect. Now, what happens if we put a minus in front of that? Well, if we put a minus in front of this, let's start with that. What we get, and I'll just barely sketch this in. What we get is we get a reflection in the x-axis. So if we make that y equals negative log x, this is flipped, if you want to put it that way. It's a reflection in the x-axis. And so if we come back to this and say, well, what have we got here? Well, we've got this dilation, and we've got the points up here being moved. Sorry, the points up here being moved to down here, and the points here being moved to up here. A simple reflection. So that brings us to what happens with the 4x. Well, that has the effect, just as this moved this away from the x-axis, this moves the value of our function towards the y-axis by a factor of 4. So our point of intersection on the x-axis is not 1, but I'll write it in here, 1 over 4, 0. And so, to finally cut to the chase, as they say, this is what the graph of y point right to it, y equals negative 3 log 2 4x looks like. And this point here is 1 over 4, 0. So the process is that this has been dilated, it has been reflected, and it has been translated towards the y-axis. So what this exercise has done, hopefully, is it's given you an idea of the basic effects of the various changes that we made to the basic equation y equals log of x. What we haven't dealt with is what would happen if we, say, put plus or minus a number out here. We'll come to that in a subsequent video. But for the moment, the answer to our questions, what does negative 3 do? Well, it reflects and dilates this. What does the 4 in 4x do? Well, it moves the graph towards the y-axis, and it's a factor dictated by this number here. Okay, well, thank you for watching. I hope that this clarified what can be a slightly confusing topic. And if you found it useful, please like and subscribe, and I'll see you on the next video. Bye.